Hello, everybody. Welcome to Algebra 1. Today we're going to be going over the Unit 3 practice test, the Part 1 problems. Couple quick things. Make sure you are reading through your weekly announcements. There's a lot of important information that is put in those weekly announcements to help you. Also, make sure you are reading through your emails daily. We send you lots of emails to help you with lots of announcements in those as well. For today, you want to have your Unit 3 practice test printed out. So you will want to go to Unit 3 under Content, and then you're going to be going to, it's Lesson 3.09, and then you will download the practice test and print out your practice test. You want to write directly on that paper underneath each question is where you'll show all your work. Remember, if your printer is not working, you've run out of ink, you don't have a printer, you can do all the work on a blank sheet of paper. You want to make sure you write the title of the assignment. You want to make sure you copy down all the problems, so that includes the questions, and show all the work. And then you'll scan it and save it like usual. If your scanner's not working, remember you can take a picture with your smartphone, and then there is that app, it's called Genius Scan, that you can use that takes a picture and then it converts it to a PDF, and then you can email it to yourself. Remember also, all TGAs must be handwritten, a single PDF, and labeled correctly in order to be graded. So if you need some help with that, check the class announcements. If you need to, go ahead and pause the recording now to make sure you have the Unit 3 practice test printed out. Why should you be here? The Unit 3 test is Friday, October 12th, and there is only one part to the test for this unit. So there is only part 1, which is the computer graded portion, and if you notice, there's only part 1 on your practice test. There is no Unit 3 part 2 test for this unit. Part 1 on the practice test is very similar to Part 1 on the actual test, questions number 1 through 12. All the problems on the practice test are almost identical to the real test. Same problems with just different numbers. I'm going to show you all the work needed for each problem and the solutions. You can use your practice test as notes when you do Part 1 on the actual test. So you have that example to help you when you're going through the real test. And you may get extra credit for correctly completing the practice test. Sorry, honors. In order to get the 10 points extra credit, you must show all your work on all the problems in order to receive the credit. You must have the correct solution with all the work. No partial credit is given. It's either all or nothing. Looking at number 1, we're given that a line contains the points -12, -60, and 60, -42. We are asked for the slope of the line in most simplified form. In order to find this, we need to know the slope formula. So remember, the slope formula is right here. That's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The first thing we want to do is we want to label our points on our ordered pair. So since this is our first x, this will be x sub 1, and this is our first y, so it's y sub 1. This is our second x, so it's going to be x sub 2, and our second y, so it's y sub 2. Now we're just going to plug it in to our slope formula. So our slope is equal to, and it's y sub 2, which is -42, minus y sub 1, which is -60, over x sub 2, 60, minus x sub 1, which is -12. The first thing then we want to do from here is notice that both on the numerator and denominator we have minus a negative. Remember, anytime you have a minus a negative or a negative times a negative, that's going to become a positive. So both of those become a big positive, leaving us with negative 42 plus 60 over 60 plus 12. Then from here, we have negative 42 plus 60, which comes out to 18 over 60 plus 12, which is 72. Now we just need to simplify it as much as we can. So we want to think of what number can we divide both 18 and 72 by. This one, there's a lot of numbers that we could, so we want to think of the largest number. And we can divide 18 by 18 and 72 by 18. So that's going to be the largest number, which is going to help us simplify it as quickly. Simplify it most quickly, the quickest way. So 18 divided by 18 is 1. 72 divided by 18 is 4. Therefore, our slope is 1 over 4. For number 2, the question is, what are the x and y intercepts of the line described by this equation? 4x minus 3y is equal to 12.3. We're first going to find the x-intercept, and in order to find the x-intercept, we're going to let y equal 0 and then solve the equation for x. What that means is wherever we see y in our original equation, we'll replace it with 0. So we'll have 4x minus 3 times y, so it's going to be minus 3 times 0, is equal to 12.3. Now from here, we're just going to solve for x. So 3 times 0 is 0, so that leaves us with 4x minus 0 is equal to 12.3, or 4x is equal to 12.3. Then in order to get the x by itself, we will divide both sides by 4. And we're going to get x is equal to 3.075. When you're working on this on the test, it'll already have like the x-intercept, and then you're just going to enter in the number. So all you'll put in is you will put in the number when you're completing your test today. Now we're going to find the y-intercept. To find the y-intercept, we're going to make x equal to 0 and then solve for y. That means wherever we see x in our original problem, we'll replace it with 0. So we have 4 times x, which becomes 4 times 0 minus 3y is equal to 12.3. 4 times 0 is 0, so that's 0 minus 3y is equal to 12.3. This just becomes negative 3y is equal to 12.3. In order to get y by itself, we'll divide both sides by negative 3. And we'll get the y-intercept is equal to negative 4.1. And the same thing when you are completing your test for number 2, you're just going to enter in the number. You don't need to put y equals. I'll just put the number directly. Looking at number 3, we want to graph y minus 4 is equal to negative 2/5 times x minus 1. Now looking at this equation here, notice that it's very similar. It is in point-slope form. Remember, point-slope form is that y minus y sub 1 is equal to our slope times x minus x sub 1, which is another variation of what we have here. This is what we've been seeing it as, where your y and your x stay the same, your x sub 1 and your y sub 1 are a point, and then your slope is your slope. So if we have something like this, we can identify our slope, which is the number in front of the x terms, that -2/5. We can identify our slope, we can identify a point, and we can plot it that way. There's no need to change it to any other form, so we can just do it from here. Remember, your point, this is where it gets a little tricky. Your point is the opposite of what it's saying. So since this said x minus 1, since it's minus in our form, it becomes the positive. And x or y minus 4, that's going to become positive 4. So our point is 1, 4. The one thing you want to remember is that it's always going to be the opposite sign. So since this was a -1, our point was +1. Since that was a -4, our point became a +4. Now we can use our point and our slope to help us plot our graph. Remember, we can't plot our slope yet. We can't do anything with our slope until we have a point plotted. So let's first plot 1, 4. So we go to the right one since it's positive, and up 4 since that one was positive as well. Now from here, now we can use our slope to help us plot another point. Our slope is -2/5. So remember, slope is rise over run. From our ordered pair of 1, 4, we're going to go down 2, since it's a negative, down 2, and to the right 1, 2, 3, 4, 5. And we can plot a point there. From here then, we have our 2 points. We can take a straight edge and we can connect those points, making sure you are doing a line so it has the arrows at the end. Moving on to number 4, we want to graph y equals 1/4 x minus 6. Notice this one is in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where b is your y-intercept and m is our slope. Very similar to number 3, just in different forms. So instead of the y-intercept, number 3, we were given a point. So here we're going to identify our y-intercept, which is -6. And our slope, which is the number in front of the x, 1/4. The first thing we want to plot is our y-intercept, because remember, we can't do anything with our slope until we have a point plotted. So we go down 6. Our slope is rise over run, so it's +1, so up 1, and then to the right 1, 2, 3, 4, and we can plot our point. Take our straight edge, make sure we're graphing a line so it has the 2 arrows at the end. Looking at number 5, we have -6 plus x is equal to -2y minus 4. So right away when we look at this equation, it doesn't look like any of the forms that were given standard form. So remember we have these three forms. We have standard form, which is ax plus by equals c. We have our point slope form, which is what we had to do for number 3, which is the y minus y sub 1 equals to m times x minus x sub 1. And then we had slope-intercept form, which is what we did for number 4. The y equals mx plus b. This equation right away doesn't look like either one of our three forms. So what we're going to have to do is we want to rearrange it to one of those forms in order to help us graph. Typically, the quickest way is going to be slope-intercept form. We want to rearrange the equation to get the y by itself. And then once we have it in slope-intercept form, we can identify our y-intercept, we can identify our slope, and then we can graph it. So we're going to take negative 6 plus x is equal to negative 2y minus 4, and we're going to rearrange the problem in order to get the y by itself. What we want to do is we want to look at what's attached to the y. So we are multiplying that y by negative 2, and then we're subtracting the 4 to it. Remember, we need to undo any addition and subtraction first. So we need to get rid of this minus 4 first by adding 4 to both sides. When we add it to the left-hand side of the equal sign, we want to make sure we line it up under its like term. So line it up underneath that constant. Now we can combine like terms. Negative 6 plus 4 gives us negative 2. So we're left with negative 2 plus x is equal to negative 2 times y. In order to get the y by itself now, we need to get rid of that multiplying by negative 2 and divide both sides by negative 2. Now when we divide our left-hand side, we have to divide every term by negative 2. So what that's going to look like is on the left-hand side, negative 2 divided by negative 2 leaves us with positive 1. And then what we have here, this looks a little funky right now. This is the same thing as minus 1/2 x. An x divided by negative 2 is the same thing as a negative 1/2 x. And that's going to be equal to y. We have it in slope-intercept form, but it just looks a little different. So I'm going to rearrange it, and we're just going to switch it so it's y equals 1 minus 1/2 x. So all we did is we just used the commutative property. We just switched them. Then from here, we want that group of x's to come first. So that becomes negative 1/2 x plus 1. This 1 was positive, so that becomes plus 1, and then that negative went with our slope. So negative 1/2 x plus 1. This is now in slope-intercept form, so we can identify our y-intercept, which is positive 1, and identify our slope, negative 1/2, and we can graph this equation. Plotting our y-intercept, we go up to 1. Then from here, we're going to use our slope to help us find one more point. So go down 1, since it was negative 1, and to the right 2. Take our straight edge. Making sure we draw a line with arrows at the end. Number 6 says, Mrs. Gibbs goes to the store to buy AA and 9V batteries. She needs at least 6 AA batteries In all, she wants to buy at least 20 batteries. The store has 12 AA batteries and 15 9V batteries in stock. So this graph shows the feasible region where X represents the number of AA batteries and Y represents the number of 9V batteries. So all these graphs, there's a total of 4 on here, represent everything that was in this first paragraph up here. So they already drew that graph for us. Moving on, let's look at what the question is asking. Which ordered pairs meet all the constraints and make sense in the context of the situation? Once again, they've graphed everything for us. Now we just want to know which of these ordered pairs are within our solution set. So remember, the solution set is where your graphs intersect. So our solution set is this whole area where the shadings all intersect. It's like this little, it's not a triangle, this little quadrilateral down here. So what we want to do is we're going to go through each of these ordered pairs and we're going to see, is that ordered pair in our solution set? So the first one we'll look at is 7, 13. So 7, 13 is right here. And this one is a part of our solution set. It goes directly on the line, but it is a part of the solution set because notice that the line is a solid line. So that means that it is included. So 7, 13 works. So we would check off that one. Now let's look at 8, 11. So 8, 11 is right here. Notice that it is not a part of the shaded region, which means it is not a part of our solution set. Next we have 10, 16. So 10, 16 is up here, which is outside our solution set because it's not a part of the shaded region. And then lastly, let's do 12, 12. So 12, 12. It goes directly on our line, but once again, our line is a solid line, so it is a part of our solution set. So for number 6, what you want to do is you're just going to go through each of the ordered pairs and you're going to plot it on the graph and see, does it line up within your solution set? Or if it's on a line, make sure that that line is a solid line. Number 7 asks, what is the point slope form of the line with the slope -1/8 that passes through the point -2, 1? The first thing we need to know is we need to know what point slope form is. So remember, that's y minus y sub 1 is equal to m times x minus x sub 1, where y sub 1 and x sub 1 are our point, and then our slope is the m. So this is going to be our m, and then our point, this is our x sub 1, this is our y sub 1. When we plug this into the formula, the y stays the same, so that's y minus y sub 1, which is 1, is equal to our slope, -1/8, times x minus x sub 1, which is -2. The only thing then we need to do here is we need to make this minus and negative become a positive. So that looks like y minus 1 is equal to -1/8 times x plus 2. This is point slope form, so we don't need to do any other rearranging. This is it. For number 8, we're asked which ordered pairs are solutions to the inequality y minus 2x is less than -1. Select all that apply. So what we're going to need to do here is we have 5 ordered pairs that we're given. We need to plug in each of those ordered pairs to our inequality and see if it comes out true. So let's start off with A, and that's 1, 0. Remember, the first value is your x and the second one is your y. So wherever we see x, we're going to replace it with 1. Wherever we see y, we'll replace it with 0. So we have, is 0 minus 2 times 1 less than negative 1? So 0, that goes away, negative 2 times 1. So is negative 2 less than negative 1? And if we think on a number line here, we have 0, negative 1, then negative 2. If something is on the left of a number, then it is less than. So negative 2 is to the left of negative 1, so it is less than, meaning this is a true statement. So A works. Now let's look at B here. B is negative 1, 0. So is 0 minus 2 times negative 1 less than negative 1? 0, that goes away. Negative 2 times negative 1 is 2. So is 2 less than negative 1? That is not true. 2 is greater than negative 1. So B does not work. Let's look at C here. For C, we have 3, 2. So is 2 minus 2 times 3, is that less than negative 1? So this one we have a couple more steps here. So we have to do the multiplication first. So 2 minus 6, is that less than negative 1? 2 minus 6 is negative 4. Is that less than negative 1? So if we think of a number line again, we have negative 1, negative 2, negative 3, negative 4. Remember, if it's on the left of a number, then it's less than. So negative 4 is on the left of negative 1, meaning it is less than. That means that C works. Let's look at D here. So D, we have negative 2, negative 4. Is negative 4 minus 2 times negative 2 less than negative 1? Negative 4 plus 4, negative 2 times negative 2 is a positive, is that less than negative 1? So is 0 less than negative 1? If you think of a number line here, remember we go 0, then negative 1. 0 is to the right of negative 1, so that means 0 is greater than. Therefore, D is not a solution of our inequality. And lastly, let's look at E. For E, we have negative 4, 2. So is 2 minus 2 times negative 4, is that less than negative 1? So 2 plus 8, is that less than negative 1? Is 10 less than negative 1? Any positive number is always going to be greater than a negative number, so 10 is not less than negative 1, therefore E does not work. So our only two possibilities are A and C. Number 9 says AJ is buying rulers and erasers at an office supply store. Rulers cost $1.15 and erasers cost 39 cents. He can spend up to $11 on these items. We're going to let X represent the number of rulers and let Y represent the number of pens. What is an inequality that represents this situation? So all we're doing for this is we're going to write an inequality. We don't need to solve it. We're just going to write an inequality with X representing number of rulers And then y represents the number of pens. So we know that one ruler costs $1.15. So how we would write that, it's just going to be $1.15 times x. If we get two rulers, we'll just multiply it times the $1.15 times 2. If we were to get three rulers, we'd multiply $1.15 times 3, and so on. And then we're going to add that to how much the pens cost, which is 39 cents, so 0.39 times y. He can spend up to $11. So we know that on the other side of the inequality is going to be 11. But now what we need to figure out is what inequality we can use. And that's the key word here, up to. This is saying that it can't be more than. He can't go over $11. He only has $11 to spend. So it can be less than $11 or it can be exactly $11. Therefore, our inequality is less than or equal to 11. And that's our inequality for number 9. Number 11, we want to graph the inequality y is less than 4 minus 2x. So we want to think of it in the form, slope-intercept form, y equals mx plus b. Notice that the x is on the right-hand side of our equation. So what we want to do is we just want to rearrange it, and we're just going to switch it. So what that looks like is y is less than negative 2x plus 4. Now we can identify our y-intercept. So our b is 4 and our slope is negative 2, and we want to think of it as a fraction, so negative 2 over 1. And we can plot our points. So we have positive 4 as our y-intercept, and then for our slope, we'll go down 2 and to the right 1. Now when we plot our graph, remember it's less than, so it's going to be a dotted or dashed line. It's not going to be solid, so we need to make sure it's a dotted or dashed. And then we need to determine where we're going to shade. Since it's less than, it's going to be everything down below the line. So shade everything underneath our inequality sign, or our line. And that is number 10. For number 11, we have to write our system of linear inequalities that's represented by the graph. So what we want to do here is we're going to identify the y-intercept and the slope for each of our graphs, and we're just going to write our inequalities. So let's first, I'm going to make this one red. Let's do this one first, and it's a solid line, so we know it's going to have or equal to. And if we identify our y-intercept here, that y-intercept is going to be negative 1. And then to determine our slope, we could go to this nice ordered pair here. Remember, we learned how to determine our slope in Unit 3. So we want to find a nice ordered pair, and we can go up 1 to the right 2. So our slope is going to be up 1, right 2, so 1/2. Now we can write that in slope-intercept form. So it's going to be y. We're not sure of our inequality symbol just yet, so we can just say 1/2 x minus 1. And now we need to determine the shading. Is it less than or greater than, or less than or equal to, or greater than or equal to? So notice the darker part of our whole solution is down here. So this one is going to be less than or equal to because it's a solid line. So now we'll do the same thing for our other graph, and this one I'm going to use blue. It's kind of hard to go over this one in blue, but if we make this one blue, our y-intercept is down here at -4. And since our graph goes through this same nice ordered pair of 2, 0 here, we can use this to help us find our slope. So we go up 1, 2, 3, 4, and to the right 2. So up 4 to the right 2, and that reduces to 2. So our slope in this case is 2. And writing this inequality, it's going to be y. We don't know the inequality just yet, so we can do 2x minus 4. Since it's a dotted line, we know it's not going to have that or equal to underneath. Now we just have to determine if it's greater than or less than. So since this shading is above that point, we know it's going to be greater than. So writing our system of inequalities, now we can just put them together. We have y is less than or equal to 1/2 x minus 1, and y is greater than 2x minus 4. Lastly, number 12 asks which graph represents the solution set of the systems of inequalities. We have y is less than -3x minus 2, and then we have y is less than or equal to x minus 2. So what we want to do here is we want to see, can we eliminate any of these graphs right away? So we know that the first graph, the top one, it's going to be a dotted or dashed line, and the bottom one is going to be a solid. So let's check to see, make sure we have one dotted and one solid. Okay, and we do on all of them. So we can't eliminate any based off of the type of line. So now let's look at the y-intercepts. For our top equation, or the one on this one here, our y-intercept is -2. And then our other one, our y-intercept is also -2. So let's see, both of these are at -2. This one's at -2, but notice this one is at -3. So we can eliminate this one. Both of these are at -2 down here. Same with this one. This one's at -2, this one's at -3, so we can eliminate that one, leaving us with two possibilities. For this one up here, our slope is -3/1, so let's make sure the lines are correct. So we would go down 3, 1, 2, 3 to the right 1. This one works. Down 1, 2, 3, and to the right 1. This one works here. So now let's check our shading. This one is less than, which means it's everything below our dotted line. Everything below our dotted line is going to be to the left then. This one down here is showing everything above the line. So it can't even be that one. So our solution is that first one. So for number 12, when you're working on this on the test, you can just start eliminating. First, check to see if you can eliminate based off of the type of lines and see if there's any graphs that don't match up. And then you can go check the y-intercept. Does the y-intercepts match up? Then check the slope. Do the slopes match up? And check the shading, where the shading is at. These two graphs were the exact same thing, but it was how they shaded it. So you have to be careful on the shading. So now that we are done, that is it. There is no part 2 for the test. There's no part 2 for the practice test. There's no part 2 for the Unit 3 test. So now that we are done, you can submit it. Make sure you are submitting it correctly for that extra credit. Sorry, honors, not for you. Remember, it is all or nothing for the extra credit. You should have everything that you need in order to make sure that it is correct. Remember, you can use your practice test as notes while taking the part 1 of the actual test. There's no part 2, as long as it is your practice test and not somebody else's. While you're taking the test, look for a similar problem to help you. If you have any questions, email your teacher and have a wonderful, wonderful day.